Hello. In this video series, we're going to talk about Gauss 2024 selected problems from grade 8. Grade 7. And there will be another video talking about grade 8. And here, let's have a look at the problem number 8 from grade 7 paper first. So we've got a sequence of symbols, and there is a repeated pattern, and we are going to look for the symbol number 23. And we will see that the pattern has a group of 5. So 1, 2, 3, 4, 5, it's a star, and then it goes back to a circle. So we've got a group of 5. It means that a symbol number 23 is equivalent to symbol number 3, because 20 is divisible by 5. So it's like 3 and 8 and 13. 18 and 23. So 23 is equivalent to number 3. And this is number 3. So it's a square. It's a crossed off square, which is a C. Okay, we don't even need a paper for this. And now let's move on to problem number 10. A number is randomly chosen from the list, and the probability that the chosen number is divisible by 2 or by 3 or by both of them is. So let's see what number qualifies. 1 doesn't qualify. It's not divisible by anything. 2 is divisible by 2. 3 is divisible by 3. 4 is divisible by 2. It's an even number. 5 has nothing to do with 2 or 3. 6 is divisible by both, but we just counted once. And 7 is a prime number. It has nothing to do with them. 8 is divisible by 2, and 9 is divisible by 3. So it's 1, 2, 3, 4, 5, 6. It's 6 out of 9. 6 out of 9, if you would like to simplify it, is 2 out of 3, 2 over 3. But see, the options here are not simplified, so just pick C, 6 over 9. That would be the correct answer. Okay, the next page. So we are at, oh, wait a sec. Okay. Now we are at problem number 14. The number 385 has 3 prime vectors, and what's the sum of them? So actually, just by looking, we can see that 8 is a 3 plus 5. 3 plus 5 is 8. It means that 385 is 35 times 11. And 35 can further be factored as a 3 and 5. 3 times 5 and then 11. So just to add up all 3 of them, that is 26. So the answer would be B, boy, 26. Just add them up. Okay, so let's move on to the next problem. We've got a circular spinner, and it's divided into, 12 identical unshaded sections and 3 identical shaded sections as shown. Okay, so basically we've got everything here. And each unshaded section, each white section is 3 times the size of each shaded section. Okay, so here the expression is kind of confusing. And the word size is used, but we are not quite sure by size. Does the problem mean area, the area, or the angle? But it is actually not confusing, because you will see that the area is proportional to the size of the angle, to the measure of the angle. See, this is a slice of pizza. Let's say it's a sector, and here we've got an angle. This angle, let's say it's theta. Say its size is it's theta, and this is r. This is the radius. So what's the area of this slice of a pizza? That would be theta out of 360 degrees times the total. By total, I mean the circle. That is pi r squared. This would be the area. So you will see that this is a constant and this is a constant. Okay, we can rearrange them a little bit. So what comes after is a constant. R is a fixed value here because we've got a spinner here. And this is the theta. So the larger the size is, the size of the measure of the angle is, the larger the area is. So it is just a proportional, and it's a linear relation. So by saying size, it could mean the area, or it could mean the measure of the angle, but it actually makes no difference. It's just a 3 times. So we know that in terms of the area, the white is a 3 times that of the shaded part, or in terms of the measure of the angle, still it's a 3 times. The white has a 3. The white angle is 3 times as large as the shaded angle. And now we would like to know the probability that the arrow stops in a shaded section. So it's not hard at all, just to see. Let's see how many shaded sections do we have here. It's 1, 2, 3, just the 3 portions. So in terms of shade, we've got 3 of them. And how about the white part? We've got 1, 2, 3, 4, 4, 4, 4, that's 12 pieces. But each piece is 3 times. So it is 12 times 3 in terms of the white. In total, that's 12 times 3. That is 36, right? And in terms of the probability of it stops in shaded section, that is 3 out of total. 3 out of, not 36, it is 3 plus 36. This is the whole circle, and this is the shaded area. That is 3 out of the 39. That is 1 out of 13. So let's see, 1 out of 13. So we should pick D as the correct answer. Okay, it's not actually a geometry problem. It's just an algebraic problem. And now let's move on to the next one, which is problem number 18. Okay. Well, wait, okay. It drops again. Okay. The Gauss bot factory assembles robots. Each robot comes in one of the 3 colors, and each robot also has a number stamped on its head. And the nth robot assembled in the first is the first robot to have the same color and the same number as a previously assembled robot. What is the greatest possible value of n? So basically that is what is the latest possible occasion that there is a repetition, okay? If we are not quite lucky, then maybe the second robot is self-same as the first robot. And that is super unlucky situation. In that case, it's just 2. The second robot, n is 2. But if we are lucky enough, and then we can keep avoiding repetition, and till some point, we can not avoid repetition anymore. And basically that is a pigeonhole principle problem. And the total number of different cases would be 3 times 4, okay? 3 colors times 4 numbers. So we can manufacture 12 different types of robots. And when it goes to robot number 13, this robot has to be the same as one of the previous. Suppose, like, say, we have all 12 of them, each by one of each, and for the first 12 robots, there's no repetition. But from the next robot on, there must be a repetition because we don't have any other choice. We don't have any more types of robots. It's just 12 of them. So the 13th must be a repeated one. So based on the pigeonhole principle, the greatest possible value of n is 13. It is 13 would guarantee a repetition, that is to say. Okay, so the answer would be C. Okay, so let's move on to the next one, which is problem number 19. It's a 5. 5 different integers in a list have a median of 10 and a range of 7. And what is the smallest possible integer in the list? The smallest one. Okay, so we are looking for the small. We've got 5 of them. The middle one and the median is a 10. And C, we've got this. And the range is 7. So it is a window of 7. And we would like to make this one as small as possible, but not too small. I mean, because this the reason is that if this one goes too small, say if this one is a 0 is small enough, it looks good, but it is not good at all. In fact, 0 plus 7 would be a 7. So you see, the range is fixed. The window has to be a 7. It's a window of 7. So if this is a 0, this would be 7. And this is too small because you see, this is the median. And this one has to be at least, let's say, this one has to be at least 12. I hope you can understand this. Let's see. Because we've got 5 different integers. So this number has to be strictly bigger than 10. It can't be 10 anymore because they are different from each other. So n is an integer, it's a whole number. So it has to be at least 11. And for the same reason, this one has to be at least 12. Okay, it cannot go too low. At least 12. In that case, if this is a 12, then this number would be 12 minus 7. And if this is x, if this number is x, whatever this is, this number would be x minus 7 because the window is fixed here. And if this is 12, this would be 5. And 5 would be good. And it is possible, say 11, 12, right? 5, 10, 11, 12. This can be whatever, say 6, 7, 8, 9. You can just pick one from 4. And this sequence would satisfy everything that has been said in the problem. So the smallest value, possible value of the lowest number would be 5. It can't go any further down. Say what if it was 4? If it was 4, then this would be 11. And 11 is not good because there is still a number in between 10 and 11, and there is a contradiction. So, I mean, this number can go lower, as low as 12, and it follows that this number can go as low as 5. So the answer is 5, which is B, choice B. Okay, so let's see problem 20.